All right. So in section 1, 2, we're talking all about data. Okay. So we're collecting this data. And when I collect it, what kind of data is it? Like, what did I collect? Did I collect numbers? Did I collect words? And then that actually plays a role in what kind of graphs you can make and what kind of calculations you can do. And you, as a worker in your job, will have to decide, like, okay, here's my data. What can I do to prove something from this data for my boss? So it's very important that you understand your types of data and what goes with that type of data. So you will be asked a lot, what is this type of data? And then you will be asked a lot, um, you know, this, yeah, I guess, present it in a graph and you'll have to know which kind and things like that. So let's look at this. So in the section where you were picking the population and the sample, right? Like which one's which, you were also given the parameter in a lot of those as well. And a parameter is a numerical measure describing a characteristic of the whole population. So a parameter might be 50% of the births that are born are female, okay, and 50% are male. Whereas a statistic is all about the sample. So we know it's really hard to get an entire population. It just is. There's always going to be somebody that says, I'm not doing that survey or whatever it is. So we always do a sample of our population, and then we get, like, maybe there were 51% of females born or something like that. We have that statistic that comes from the sample. So parameters from the population, statistics from the sample. What do we have the most? Right here, statistic from the sample. Now, later in the chapter, we will get stuff about the population that you'll compare it to. Okay. So quantitative data. This is data, quantitative, or sometimes called numerical data, that consists of counts or measurements. So counts or measurements becomes really important. So is it numbers? Are you, and meaningful numbers? My favorite number is not meaningful. That doesn't have a meaning. I can't find the average favorite number by adding and dividing. It doesn't make sense. So anything but that. So counting, my examples could be the weights of supermodels. I got this from the book because I don't think I would ever pick that. Maybe the weights of normal sized women. Example, the ages of respondents. So that might be really important if you're doing a project on people that responded to your survey, like whether we should allow another liquor license, and everyone who responded is 20. That would be important information versus everyone who responded is over 55. So you can see the importance of that, and that it's a number that you're collecting. So it's quantitative when it's a number. Okay, so then the next one, qualitative or category. Those are kind of bounced between on what textbook, and in some of our projects and homework, you need to know both words. So quantitative would be like, it's not numbers, like genders. So I had this survey and this many females, this many males responded to my survey. Or I'm collecting this one says shirt numbers for professional athletes. Um, whatever it is. Am I collecting something that is a label, right? Or a name? So the label or the name could be even your favorite color, or what color of hair most people have in our class, or something like that. So category data, you can't do all graphs with. It's not numbers. So there's a lot of graphs you can't do. You could do a circle graph and you could do a bar graph. And that's about it with category data. Whereas quantitative data, you'll be able to do all sorts of different calculations and graphs. And we spend most of our time on quantitative data. Okay. Still have to be able to work with category or qualitative data as well. So Quantitative data can be further described by distinguishing between discrete and continuous. So this is really more of an advanced idea here, because as you study more statistics, if you took a higher level than just intro, you might have to do some continuous. We don't do it in this class at all. We just do discrete data. So let's describe what they are. Discrete data results when the data values are quantitative or the number of values is finite. So can you count the number of values? Everything we do will be in this world. Okay, so discrete. The number of tosses of, you're tossing a coin, right? The number of tosses until you get a heads or a tails, a specific one. It's usually like, gosh, now I can't think of another one. Almost everything is discrete now. I'm drawing a blank. So if I'm collecting data that is how tall people are, well, it's countable because you only have so many people in your sample. Your sample doesn't go on forever because there aren't infinite many people. There's a countable number of people. Okay, so continuous results from infinitely many possible quantitative values. For example, the distance between two numbers. Yeah, always could find another number. There's infinitely many. So this continuous world is not where we live, because we usually are talking mostly about people and what people do and how to prove or disprove. I guess you don't prove, show evidence of or against something, some kind of idea that somebody has. So continuous doesn't happen a lot, but you can distinguish on quantitative between those two. Another thing you can do is levels of measurements. This is another way to classify your data. And we have 4 different measurements: nominal, ordinal, interval, and ratio. So nominal is our first one we're looking at. And nominal is characterized by data that consists of names, labels, and categories. So you have a survey, yes, no, undecided, something like that. You like your teacher on a scale from 1 to 5. That is, well, no, we shouldn't say it that way. They can't be arranged in some kind of an order. So it wouldn't be 1 to 5. It'd be like a yes, no kind of question. Because that'd be our next one. So characterized by, it's got names and labels. So I get this data and I ask you, is it nominal? First thing you look at, does it have labels? Is it a category or qualitative, excuse me. And it can't be arranged in some kind of order. That's nominal. Ordinal is similar. Okay, so ordinal is also going to be qualitative data or category data, but you can find meaning between them. So I was saying like 1 to 5, ranking something, but involve data that can be arranged in some order, but differences obtained by subtraction can't be determined are meaningless. So you could put them in an order. I keep wanting to use the 1 through 5, and I don't want to use that on this one, because you can subtract them and have meaning. So if we're looking at grades, A, B, C, D, F, right? Can I subtract an A and a B? I don't know. What do you get? A B plus? No, it doesn't work. But we can put those in order. And it has meaning to say A, B, C, D, F. It has meaning. So if you have collected category data, you are here or here. This is categories. Okay. Interval and ratio. Interval and ratio are going to both go into our world of quantitative numbers. Okay, that looks like chicken scratch. Quantitative. Okay, so interval, let's look at this interval. An interval involves data that can be arranged in order, and the differences between the data values can be found, and they are meaningful. However, there's no natural zero or starting point. None of the quantity is present, at which none of the quantity is present. Oh, okay. So you don't really have a starting point. So interval levels, the best example really is years. Interval we don't see very often because it doesn't have a starting point. Most numerical things that we do have a starting point. So interval, they're numbers, so they're quantitative, and there's no natural starting point. I'm trying to think of something other than years, but what doesn't have a natural starting point? This is definitely not what we'll see most of our data, because I can't even think of one right now. I keep wanting to do that other example. It keeps coming to my head and it doesn't fit. So ratio, what is a ratio? Well, it involves data that can be arranged in an order, and the differences between them can be found and are meaningful. However, there is a natural zero starting point, where zero indicated that no quantity is present. And so everything is meaningful, full numbers. This is the world that most of our samples will live in. They'll probably either be categories nominal or ordinal, or they'll probably be ratio. That's most of our data that we collect, because ratio, the example I gave here is class times. So 50 minutes and 100 minutes. So class times, right? The difference between them makes sense. So I'm in this class 15 minutes longer than the other. That makes sense. And it has a natural starting point, 0 minutes. So most things have a natural starting point except time. I mean, yeah. Okay. Here's my little shortcut. And you'll be allowed a note page on the test. So you could put this little, notes here, and that should be enough to help you after you've done the homework and kind of look through the different categories. Okay. So I collect my data. It's quantitative or qualitative. If it is quantitative, it can be discrete or continuous. We live in a discrete world mostly, right? And all of our data, not just quantitative or qualitative, are either nominal, ordinal, interval, or ratio. So one of those four. And being, if it's collecting numbers like, I don't know, the times people finish a race, ratio, right? You're collecting weights, ratio. You're collecting heights, ratio. I mean, a lot of things we collect data of is ratio. Amount of sugar in items, ratio. Hair colors, nominal. So you can't put hair colors in some kind of order. You can't be like, well, because I have brown hair comes first, it just doesn't work that way. Okay, big data. Moving on to a different idea. Big data. Big data refers to data sets so large and so complex that their analysis is beyond the capability of traditional software. Analysis of big data may require software simultaneously running in parallel on many different computers. Data science involving applications of statistics, computer science, and software engineering, along with some sort of relative field. So big data is, people always talk like, oh, big data, right? We can't actually analyze that. You need special software and tools. And we actually have StackCrunch, and we have a software tool that will allow us to do massive data amounts, but this is bigger. So the idea of big data is just so much to analyze. Okay. Missing data. So we're going to collect our data, and we have this idea of big data, and then we have this idea of missing data. All right, so I'm collecting and oops, I accidentally forget one. Or you write one down wrong, or, well, no, that would be in, yeah, something little like that. All of it's similar, but a data is missing completely at random. That is just our missing data. And then, or you could decide to eliminate that data as well. And that's why it's missing. So it could be an outlier. And you're like, yeah, I just collected how much weight girls can typically squat. And some girl recorded 680 pounds. And you're like, yeah, no, you can't. Right. So you took her out of your study. So missing data happens, and it's common. And you could be leaving them off on purpose, or you could have accidentally missed them. Correcting missing data. So you could delete cases. It's really common method of dealing with missing data is delete all subjects having any missing values. So if somebody does a survey for you and they didn't fill it all out, you just don't use that survey. It's pretty common. Missing data values, we substitute a value for them. We say, okay, well, your height was this, your weight was this, so we're going to put in this for this number you forgot. So these are just things, I think that was all that this note packet had. These are just ideas to do with data. Okay, so we know when we collect data, we're going to have errors, right? I mean, nothing's perfect. That's why statistics isn't perfect either. I'm going to give you ways to analyze your quantitative data. I'm going to give you ways to analyze your qualitative data. Is it all perfect? No. But if you don't start with a good sample of your population, your subject, your whole thing is gone. If you don't start with taking out outliers and or being truthful, or the way that you collect your data, that could be a big issue too. All right. So that's all we got for this lesson, and more on data next time.